Okay, good afternoon. My name is Bert Muller, and I'm the robotics advisor for Sure Robotics, which is a division of Sure Controls. And today I'll be guiding you through Cobots Unleashed. We have some exciting things to cover, and I'm looking forward to sharing solutions that I hope will help solve your labor and automation challenges. So many companies today are really struggling to find employees. I hear companies that just simply can't hire enough people. And some of these companies cannot run a third shift because they just don't have enough workers. So employers are really struggling to help their employees perform more value-added work instead of those just boring and repetitive tasks that no one wants to do. So before we talk about Cobots Unleashed today, we need to level set on a few different technologies. And one of those is mobile robotics, and the other one is collaborative robotics. So on the slide here, you can see that the Omron AMR, or autonomous mobile robots, there's quite a few different ones available in size, in payload, and type. And we'll kind of break that down a little bit more in a few slides coming up. So one thing to kind of cover is the type of mobile robot. And many people are familiar with the legacy AGV, or automated guided vehicle. These are the type that been around for a few decades, and they're kind of like a train on a track. So either they're following some like a metal strip that was actually poured into the concrete floor, or maybe there's beacons and other things, but they're following pretty much a set course. And there's not much intelligence to it. So if something gets in the way, they're just going to stop and sit there. Now, the AMR, or the autonomous mobile robot, doesn't use these fixed, physical guides and that sort of thing. It does it through software. So using LiDAR and cameras and things like that, it's able to scan its surroundings. And the big advantage is if it sees something in the way, it just dynamically routes around it. So it's not going to stop and just sit there and wait. It's going to keep going, and it's not going to slow down production until the obstacle is removed. Let's kind of see that in action a little bit. So this video up here kind of shows the real-time avoidance and rerouting. So here's a couple different Omron robots. You've got the HD 1500, which is the big guy. So when I say 1500, that's 1500 kilograms, and 2.2 pounds per kilogram. So that's definitely way over 3,000 pounds capacity. I like this. This gal puts this kind of cart or shelving unit in the way, and just goes right around it. So it's a little tougher fit there with the big tractor body on the back, but you can see the other robots. There's the LD250, which is 250 kilograms, and there's an LD90, which is rated for 90 kilograms. And so that allows it to route around it. Now, one other technology that I just want to throw out there is the acuity option that Omron has, and nobody has this. So these mobile robots, what they use LiDAR, kind of a scanning laser or cameras, to kind of see the surroundings, to figure out, where am I, to get its bearings. The problem is, like you see in this video up here, I'm just going to pause this one for a second, is you see there's all kinds of carts here. This is like in an airport. So these are like all those food carts and everything. Every time it comes through, it looks different. It can't see the walls. It can't see columns. It just doesn't know where it is. And other robots would just get lost. They couldn't figure out where to go, and they would just essentially stop in place. What Omron has as an option is you can get this upfiring camera, which, it adds to the scanning laser. So it looks up at the ceiling. So if you look up here, these little lines coming here, those are the overhead lights. So it's really some cool stuff. So it's actually using the overhead lights. And it's kind of like ancient mariners used to, do when they're out on the ocean. There was nothing to look at, nothing to see to get your bearings. They'd pull out a sextant and look at the stars. So really the same thing, kind of, similar technology there. So it's pretty neat. And again, no one else has that. So an autonomous mobile robot, it's able to, out of the box, it can drive around, navigate, do all those sorts of things, but it's really not going to be able to do any specific tasks. So an autonomous mobile robot has to have a topper, and that's the tool in its hand is the topper for the mobile robot. And the toppers really come in all different forms and flavors. A lot of them are application specific, but you could have shelves. You could have a little piece of roller conveyor on top. You can put a robot on top. You know, really the sky's the limit. It's really depends on the application. So it's kind of the similar analogy, you know, right tool for the right job. And here's some examples of real life autonomous mobile robots deployed. And this one up here, this is kind of for, you know, WIP, so work in progress. This is taking these bins, these totes, moving those around. There's a piece of conveyor on top of these mobile robots. Those are the Omron LD90s there. And this is taking, you know, delivering product to the work cell and picking up that product and moving it on to the next step. So this is taking the place of people picking up and having to lug this stuff around or load a shelf and push the shelf around that's on wheels. This does it all automatically. And other applications, here's actually in a Tesla Gigafactory. So this is the cart transporter. So this has a load on top, but actually the load is supported by those caster wheels right there. Sorry, the pop-up keeps coming up there with the controls. And what it does is it's able to latch onto the load, very similar to like a fifth wheeler. If you've got like, you know, see a big pickup truck like a dually or a semi. So here it's pulling out right here. And if you look right there, that's kind of the attachment point right there. So that's another option for mobile robots. And what folks are really looking to do with mobile robots is really to, you know, kind of the holy grail for a lot of people is to reach lights out manufacturing. Now that's not for everybody. There's always a happy balance between the level of automation and the level of traditional manual tasks done with people. So, you know, it's just finding what's the best balance for your particular application and industry. Now, the robot I want to cover today is going to be the Omron LD250. This is, like I mentioned earlier, this is 250 kilograms, which is rated for 551 pounds. It's a really nice platform. It's got all the advantages of Omron for navigation and you know, obstacle avoidance. So very safe, high payload, very stable, particularly with those urethane wheels that are on there. It gives you a nice stable platform. So let's talk about collaborative robots, and for just so everybody in the crowd's kind of level set on this, is there's really two main types of robots. There's traditional robots, and then there's collaborative robots or cobots. And a traditional robot's just pretty much like what you've seen everywhere. You know, I've seen big welding robots and automotive lines with sparks flying. We've all seen that on TV. Those are going to be traditional robots, and those are designed to move fast and furious. So they're going to move the payload as quickly as possible, as heavy as possible. But the rub is you can't get it in its way. I mean, it's gonna run you over or something worse. They're not designed to operate around people. So they're usually inside cages, you know, some sort of physical guarding, or using safety light curtains and that sort of thing. But if someone gets close to it, it has to stop. It cannot keep operating. The Cobot, on the other hand, is designed to work around people. So if somebody, you know, is in that envelope, the Cobot can continue to operate. It does not have to stop, but it needs to have feedback on it. So if it bumps into you or runs into something, it'll sense that and stop. So Cobots are the perfect choice for around people. The only rub with the Cobot is it doesn't move as fast or as much payload as a traditional robot. So different robots for different tasks. The Omron TM series Cobot, really a nice Cobot, leads the industry out there, particularly a couple different things with this. And first of all is the 3D vision intelligence that this has. So when we're going to talk a little bit about Cobots Unleashed, where we're moving the Cobot around. Well, with a robot, one of the first things you do is you calibrate the thing. So you have to calibrate, you know, the physical world to the robot world. So when it goes to reach and grab something, it knows where it is. And most robots are doing what's called blind picking. So it's kind of like reaching for something with your eyes closed, and you kind of go to a known spot to go pick something up. But if somebody takes you and spins you around in a circle and says, okay, go reach where you're going to reach again, and you still got your eyes closed, you're going to miss it, because you've just thrown off your bearings and your calibration. The collaborative robot, the TM series, has a built-in camera. And what this does before it goes to pick something is it takes a picture and finds this little tag. So you can kind of like stick that on the machine. And once it finds that tag, it's able to find that and, X, Y, and rotation, but also pitch and yaw. So it knows exactly where the surface is that it's reaching for. So essentially recalibrates itself, each time. So really slick, very easy to program, just point and teach. There's a button here you can click called free, and then you can move the robot arm around, move it where you want it to go, and then teach that point. So you can do a lot of the heavy lifting with the programming just by, simple point and click. Comes in different flavors. The size and payload capacity and reach vary. Today we're going to be looking at the TM12M. That's the mobile version, so it runs natively on DC power. So if you're running off a battery, DC power definitely helps because you're not running an inverter. This is going to have 1.3 meters of reach and 12 kilograms of max payload. So a little over, close to 26 pounds on that. So just like the mobile robot out of the box can drive around, look cool, do neat things, but it can't do a task until you put a tool on it. And on the mobile robot, that's the topper. Remember, we showed you like conveyors and things like that. Well, the collaborative robot, again, out of the box, you can pull it out, program it to move around, but it can't do any tasks until you put a tool in its hand. And the equivalent of that is the end of arm tool, EoAT, just end of arm tool, and many different options available. So different tools, right, for the job. So you've got different types of grippers. There's things like sanding and buffing. So you can put a rotor unit here with force feedbacks and knows how hard it's pushing down. Here we're doing some palletizing. I'll kind of pause some of these so we don't have too much action going on here. And this is a vacuum gripper, so great for lifting up a box or something like that. Up here, this is a flexible gripper. This one's by Soft Robotics. These are used a lot for picking food products or something soft. Imagine a bag of potato chips or something like that, something that's soft and conformable. And in this case, there's a screwdriver. So if you want to do screw driving with the Cobot, this is an example of that. Now, what we've done at Sure Controls, in partnership with the folks over at Omron, is we've developed the M.A.C. And the M.A.C. is a mobile autonomous Cobot. So we've taken the Cobot, which is usually bolted to the floor, and put that on the autonomous mobile robot to allow it to do more tasks and more things. So what we're trying to solve with the M.A.C. is really the problems that I would say every single manufacturer I've talked to, or anywhere where you've got people doing manual jobs, could be in a life science application, semiconductor, machining, that sort of thing. You just can't find people, or the few people you have, you don't want them running around just doing some boring repetitive task, which quite honestly nobody wants to do anyway. So using the M.A.C. to help kind of fill that void. So let's see a video of the M.A.C. in action. So there's the M.A.C. You can see there's a really nice welded frame that's on there. Really good fit and finish, built very, very strong, very durable. There you have the TM12 Cobot on top mounted to it. They were doing a task, just picking up a sample, we're putting that on top, moving that around. So that's an example of going out and picking something up. Now, it doesn't have to be a piece of metal like that. It could be a box of something, could be a bin. Here we're showing the LiDAR navigation, and that's the autonomous mobile robot rerouting around. And you can see the nice user interface in there. So if you need to access different programs or get it to program to do different things, that's the M.A.C. So the M.A.C., there's been other deployments of mobile robots before. There's been other folks to put a collaborative robot on a mobile robot, but there's every iteration, there's more and more learned. And Omron decided to pick one partner in the Americas to partner with on the MAC, and that was Sure Controls. We were chosen out of many different companies to be the one sole source for all mobile manipulator MAC applications in the Americas. And so a lot went into this. So pretty much the years and years experience Omron had, deploying these sorts of things, the years of experience that Sure Controls has, all these different things went into this to really make the MAC the best mobile cobot on a mobile robot out there. And just some of the key features of it, kind of mentioned the Cobot on top. We have the Omron TM12, which has that integrated camera and that landmark feature, which is fantastic for essentially getting your bearings again. So as you can imagine, every time you drive around with the robot, you come back to the same spot where you were before. You're never going to be exactly in the same spot. I don't know, maybe there's someone left a bolt on the floor and the robot's sitting a little kind of cocked on this, on something on the floor. Maybe it didn't, park in exactly the same spot. Maybe it's a 1/4 inch off, not a big deal. The landmark feature allows it to recalibrate to that. And, fully welded frame, this is powder coated. We put extrusions on the side so you can, add different attachments to it, or you can bolt right to the top or even into the sides. And it's got that LD250 autonomous mobile robot in there. This is just kind of looking from the side a little bit. So there you can see the HMI in it. So that's how you would interface with it, at least, during runtime. And, here's different ports. So if you need to connect a computer to it or through Wi-Fi, you got an antenna right there as well. And yeah, here's the team, at least the internal team at Sure Controls that worked on this. Yes, that does look like a barn. That's actually one of our rooms here called the barns. So Terry right here, the owner, he's got some buddies that tear down barns, old barns for a living, and they kind of decked out this room and called it the barn. So you can see they weren't messing around when they did that. But here we have you can see the MAC. So see how I walked right up to it, just stopped, and once the obstacle's out of the way, it's going to go around it. So what happened is it stopped there because it was going down an aisle and there wasn't any room to kind of get around me. So then in that case, it just stopped. In other situations, it would have rerouted around. So let's talk a little bit more about what we can do with the MAC. So we got this Cobot, we got this mobile robot, what can we do with this? And one category of application is just picking up and carrying things around. So if someone needs to go out and go up and pick up this box of stuff, they got to walk across the plant, pick this up or drop it off, whether it's, paperwork, whether it's grabbing a sample off the line and bringing it back to the test lab, going and grabbing a reject bin of parts, pulling that out, maybe it filled up. So just something where someone has to kind of walk, a ways, drop what they're doing essentially, and go take care of something. And really, you want employees doing a value-added task, and just walking around to go pick up or drop off something is not a value-added task. And again, nobody really wants to do these things anyway. So that's part of what we look to automate. So here's another video of the MAC. And in this case, right up here on the shelf, we have one of the landmark tags. And you just need to use one of those. Not every application you need to, if it doesn't lend itself to adding the tag, but the tag works really well because here you come down and watch the camera, you see a little flash of light right there. So that just took a picture of the landmark, reorientated itself to get its bearings. So it's essentially calibrated the shelves to the MAC. So if we took the MAC, drove off, came back and parked it again, but let's say we parked it, maybe a 1/4 inch off where it was last time, it's still going to come in, look at that landmark, and it would calibrate itself to the shelf again. So once you're calibrated to the shelf, now you know where all the different shelves are, and you can go in and grab those. So that's the MAC in action. And some of the other applications are really tending. So I talked about emptying a reject bin, but sometimes what you're doing is you can do something more complex. And let's say in lab automation, you might have a piece of test equipment. So you want to go up, load some trays or test tubes into the piece of equipment, use the arm on the Mac to close the door and go hit the button to start the process. That's one example. Machine tending, so CNC machine tending is a big one. But let me go to this next slide here. I've got some videos which kind of show that. So this is machine tending. So there's the robots grabbing the blank, going to load that into the CNC machine. You would have a landmark on the machine itself just to make sure you're kind of got your bearings before you go in there and try to drop it into the chuck. So put that in. You can use the arm to close the door, and there you go. Hit the button and start. And we can watch a little bit more of that. But if you're not into CNC machine tending, I don't want to keep you watching that. Oh, sorry, I just jumped ahead a slide here. Let me drop back to this. What we want to do here is another application we have is this is kind of a life science type application. Some of these are older iterations of the Mac, but the Mac we're talking about today is the latest generation of all this. But it's hard to take video at customers because there's sensitive nature of a lot of times the products that are involved. So you can see grabbing test tubes, there's a barcode scanner there, loading, unloading. And in this case, it's putting the test tubes on the mobile robot here. But what we have today, the Mac, we have the Cobot on the mobile. So you can do it vice versa. And also going and picking product off of shelves. So, bin picking, order fulfillment, that sort of thing. So these are kind of some examples of what you can do with the Mac. So when you've got a collaborative robot, on wheels, it opens up a lot of opportunities. And something else we can do with this, and this came up at a few companies, is they had cobots already, or they were thinking of adding some. And in one application, the customer needed to load and unload kind of some boxes that hold product. So they kind of load them into the machine. And what was going on is somebody would have to go there every about once an hour or so or less, and go and load and unload the machine. And so they would take these essentially boxes of product and put them onto a little roller push shelf. And that's what they would do. And so they only had to do it for 5 minutes out of each hour, and they had multiple of these. Well, instead of putting fixed cobots at each one of these positions, bolted to the floor traditionally, this is something that the Mac could do. And because now you've taken the Cobot and you put it on wheels. So because the Cobot wasn't running all the time, it just needed to load and unload once every 30 minutes, once every hour, depending on the particular spot. There was plenty of time to have the Mac go back and forth. So it could go and service one area, do that, go off to the next one, and potentially do 2, 3, or 4 areas with one Mac versus having all these individual fixed mount cobots at every one of these stations. So if you've got an application where the cobot doesn't need to run a lot, you could potentially do it with one Mac and then kind of actually end up saving a lot of money. And the Mac can be modified quite a bit. And inside of the Mac, so this is what it looks like, this picture right here. This is the side of the Mac with the cover off of it, the side panel. And you can see inside of here is an enclosure. Okay, so that's an electrical enclosure. And if you crack it open, it kind of looks like this inside. And this doesn't show the whole thing, but there's actually extra room in there as well. There's DIN rail in there, so there's extra room. And this is all 24-volt controls. So standard industrial voltage, controls. So there's a PLC in there, safety controller, all kinds of stuff's in there, but there's extra room. So if you wanted to turn the Mac into something custom, well, you could add machine vision to it. You could add a barcode scanner to it. Really, you could make this into something application specific, put a flexible feeder on top of the Mac. So you go up, take parts, pull parts off the line, maybe, you know, clip something together, then go back and drop it back off, or pull parts off the line and run it into, you know, some kind of AQI, automated quality inspection system that's maybe, you know, dimensioning parts or looking for defects. A lot of different things you can do. So it's essentially what you have is you have a robot with a control panel, but it's on wheels, so it's going to move itself around. So you could, you know, turn this into really whatever you want. And the question I get a lot is, you know, what can the M.A.C do this? And because sometimes you look at it and you're like, okay, I got this mobile robot, I got a Cobot with it, you know, what can I do? You know, there's a lot of different pieces there. And the best way is just to kind of look at each one of those separately. And, you know, the first thing to look at is the TM Cobot, and to say, okay, the place where I need to go grab something or manipulate something, you know, push the button, open the door, load product in. You know, if I wasn't even looking at the mobile robot, if I just wanted to bolt the Cobot to the floor in that spot, is it doable? I mean, can the robot reach in there? Is it within the payload capacity of the robot? You know, just those kind of same general questions. Will that work? And if you can check that off, it's like, okay, now let's look at the mobile robot. So if I didn't have anything mounted to the mobile robot, if it just looked like this, you know, this is what it looks like coming out of the box just for the LD250, can I drive it around the location? Can it, you know, fit where it needs to go? Are there obstacles in the way? You know, is there just something that would prevent the LD250 from working there? And if it's, you know, good to go, that the LD250 can navigate, you know, easily and make it through every area it needs to go, then okay, you check both boxes, and, you know, that looks like it's a good M.A.C application then. And something else we can do with the M.A.C is, you know, talk about the M.A.C is really a autonomous mobile robot, you know, with the Cobot on top, and then a whole control, you know, panel and control system sandwiched in between the two. Well, you may have an application where it's like, you know, I want to have the Cobot, I want to have mobility, but I don't need the thing to be driving around all the time. I just want to kind of park it somewhere and keep it there for, you know, hours, days, months, you know, whatever you want, but I don't need to move around constantly. I'm fine moving it myself, you know, only when it needs to be, you know, moved to a different location. Well, we have the push kit for it. So we can do the M.A.C without the autonomous mobile robot, and instead put wheels on the bottom and, you know, a handle on it and locking casters. So you can just roll it up, and, you know, this one would actually have a extension cord on it. You'd plug it right into the wall. This up here, the autonomous mobile robot, has the battery inside, and that runs everything. And when the battery starts to wear down, then it goes to the charger. In case you're wondering, this will run for at least 6 hours nonstop, at least 6. So a lot of people ask that question. So let's talk about next steps. So hopefully, you know, you kind of looked at what I talked about with the M.A.C today. And if you're like, yeah, I think I might have an application, or, you know, maybe I'm not quite sure, I'd be happy to talk to you about it. Just kind of, we can kind of spitball a little bit. Let me know what kind of challenges you have, what you're looking to do. And, you know, I'll give you some, you know, some straight answers on, you know, what I think is the best solution for you. Even if it's something that I don't have, you know, I'm more than happy to recommend something to you as well, to help you kind of solve some automation and labor challenges that you might have. So I appreciate your time today. And again, I hope you found this very beneficial. And I look forward to talking with you and helping you solve some labor challenges. Thank you very much.